What up, nerds, and welcome back to part three, a rare part three. There's a lot in astronomy that a lot of times gets condensed down. Okay, like I said, I think in my last video, I usually teach this in 2 full weeks, but I'm gonna kind of condense it down so that we can take a little bit more time with it, um, and you have more access to the info. Okay, so we're talking about rotation and revolutions and stuff. Okay, so we are going to be talking more about movements of planets and planetary bodies, starting now again with Earth and Earth's precession. Okay, so this is a weird kind of idea. Precession is the change in the direction of the rotational axis without any change in tilt. Okay, the rotational axis slowly traces out a cone. Okay? This is due to Earth's non-spherical shape. Earth is not actually a perfect sphere. Okay, it's actually bulging outward a little bit at the equator. So it's not this perfect sphere. It's a little bit different. Okay, so what you see is that Earth's axis normally looks like this, and if this is the sun, it's rotating around like this. Okay, but over time, Earth's axis will slowly start to shift and traces out this kind of cone shape as it slowly moves around. This is called precession, okay? And this means that in about 26,000 years, the seasons will entirely shift as Earth's tilt moves to the other side, okay? Completely flips. So precession is this all the way around motion, but we've also got something called nutation, and this is a weird idea. Nutation is the rocking, the swaying, this nodding, this wobble motion that is that we see in the axis of rotation of the Earth. We call this the wobble around the precession axis. So this is the axis of Earth. So Earth spins around this line. Okay, so it rotates around this line. That line will move in this kind of circle-y cone shape over 26,000 years. But while it does that, it does this kind of like wibble wobble, wibble wobble as it does. That is what is nutation. Okay. Weird to think about, but what I primarily want you to remember is that nutation is the wobble, precession is the kind of is the changing of the rotational axis, and then rotation is the Earth's spin. So the main cause for nutation is the gravitational forces from the moon, the sun, and the planets that act on the Earth. Okay, so if you actually look really carefully at Earth's nutation, at this wobble, what you'll see is that it's not just a back and forth wobble, but it's actually a little bit of like a circle, like little tiny circles, like little squiggles you might make with your own pen. But if you look even closer, each of those little squiggles is made up of smaller squiggles. So all of these little squiggles, all of these kind of pushes and pulls are caused by the back and forth motion, this push-pull that we see from the moon, the sun, planets, as they all interact with the Earth, okay? So you get this really interesting kind of wibble wobble from Earth's axis as it moves. Fascinating. Okay, everybody's least favorite idea. It's not that hard to remember, but it's difficult for a lot of people. Okay, there is this idea called Barycenter. Now, Barycenter is the center of gravity around which two or more bodies revolve. Okay, so let's back up a little. Most people, when they think about the moon revolving around the Earth or the Earth revolving around the sun, okay, so if I bring out my guys again, this is the Earth, this is the moon. Okay, most people think that as the moon orbits around the Earth, that it is orbiting around the dead center of Earth, okay, right in the middle. But that's not true, okay? That is not the point around which this is rotating, or this is, excuse me, revolving, which is a little hard to think about. The reason for this is because it is actually revolving around a point that is just slightly off center. Because as the as the moon orbits the Earth is also orbiting with the moon. It's going around this point that's in between. This point is called the barycenter. Okay, it's actually very convenient. I have something that can help explain this a little bit better. Okay, so if any of you are have like a grandparent or somebody who's a little bit older, they might have one of these. They're just called these balance birds. That's what I've always known them as. And they're very interesting because they're these little toys that have little weights in the wings and weight in the body, so that when you balance them on your finger, like so, they remain perfectly balanced. Okay. Now, the reason that this is relevant to what we're talking about today is because as I spin this, okay, some people might think that the wings are going to not have any effect on the center of gravity of this thing, but that's not true. The center of gravity on this, because it's weighted here and here, is at the point that's directly in between those weighted parts. Okay, so again, there's a weight here, and there's a weight here and here. And the point that is directly in the middle of those 3 points is the beak right here. Meaning that even though it looks like it's going to fall off because it seems like the weight is going to be way far distributed this way, balances perfectly. And I can even spin. Okay, that's the basic idea of barycenter. Is that it is the point of balance directly between the different weights, the different masses that we see in our solar system. Okay, so the moon has its own mass, the Earth has its own mass. Okay, so if you want to think about it like that with the bird, think of the wing weights as the moon, think of the body weight as the Earth. You would expect that the body weight of the Earth would be bigger and have more to it, and so that the bird would just fall off as soon as I put it on my finger. But the influence of the mass of the other body of the moon actually makes it so that there's a point in between, a balance point, and that's the point that we call the barycenter. Okay. Hopefully that cleared that up a little bit. I hope. Or it made it more confusing, in which case, sucks. Okay. But that's the basic idea. So if you're gonna, here's a great example. Jupiter is a very large planet. Okay, and the sun is a large mass in comparison to that. Jupiter does not orbit the center of the sun's mass. Okay, the sun and Jupiter both spin around the barycenter in between the two of them, which is a point that is actually just outside of the sun's surface. Okay, so Jupiter is large enough that it has a gravitational pull on the sun, and it causes the sun to move around this point. Jupiter, in return, moves around this point as well as it moves around the sun. Okay, that's the barycenter. Very confusing for a lot of people, but hopefully you can get your head around it. Okay. The weirdest thing about this is that the barycenter of the entire solar system means that the sun moves slightly as the gravitational pull of the planets in their different positions tug on it as they go around the sun. So even though the orbits of the planets look like this, where they kind of look like circles or kind of look elliptical, the actual center of mass of the sun as it moves around goes like this, where it goes crazy. So all the way back here, this was 1945. Since 1945, the sun has moved in all kinds of crazy circular motions, lots of weird round motions and like big wide sweeps and these little loops. And this is all caused by the planets pulling on it and tugging it in different directions. Because again, the sun is not sitting on anything. There's no friction in empty space. So it is just at the whims of the planets. It's moving just as much as they are. Okay. Okay, the moon and the tide. So we talked about this a little bit during hydrosphere. But the moon's gravity pulls on Earth along an imaginary line that connects the Earth and the moon. Okay. And ocean water, because it's separate from Earth itself, because it is just water sitting on top, it's pulled by the moon's gravity. And this creates bulges of ocean water, okay, on the near side and the far side. So this causes high tides and low tides. So as the moon pulls on one area of the Earth's oceans, more water gets pulled in that direction, which means that there's more water here and here, less water in the other areas. Okay. And we talked about this briefly, I think, with oceans as well. There are two types of tides, like major tides, besides like high tide and low tide. High tide and low tide is more of just like time of day and like description. Neap tides and spring tides happen with positions of the moon and the sun. Okay. So if the sun and the moon make this perpendicular kind of line, meaning that they make a right angle, you're going to get a very shallow tide change. Okay, so high tides are low, low tides are high, and it's not as big of a tide change. Whereas a spring tide happens when the moon and the sun are all in a line. They're all directly parallel. That means that the gravitational pull of the sun on the moon on the earth is stronger than normal. So we get really much more extreme tides. So high tides are very high, low tides are very low. Okay. If you've ever seen the movie Interstellar, fantastic movie. We see the most extreme version of this when they go on the water planet, and I won't explain any more than that. Okay. Okay. One of the last things that we're going to talk about is electromagnetic waves and electromagnetic radiation. Okay. So we've talked about this a little bit before, but electromagnetic radiation has a very long spectrum. It's just waves that occur all throughout the universe, classified by wavelength or frequency. Most of the dangerous ones, most of the extreme ones, are blocked by the Earth's atmosphere or by its electromagnetic field, its magnetic field. Okay, but what does get through usually is infrared, visible light, which is the one that we can see, and ultraviolet. Okay, UV rays. And that's the very, very basics of it. Okay, so there's a little bit more here and there that I would potentially want you guys to know, but this is the very basics of astronomy. The slapdash, bing, bang, hit 'em hard, basic information you need to know. There will be more stuff in your Canvas module, okay? Keep an eye out for this particular module because I'm going to be updating it twice. I'm uploading it today at the beginning of the week, and then I will update it again next week with a couple extra things, okay? So keep an eye out, but thank you guys for sticking with me and sticking with this throughout this weird period in education. And again, if you have any questions for me or any concerns, make sure you text me, email me, DM me, whatever you need to do. I will answer your questions as soon as I can, okay? But until next time, stay wonderful, stay curious, stay fantastic. Love you all. Stay safe.